Over a mere 72 hours, a pair of stellar explosions burst forth with enough intensity to become visible without aid from the naked eye. Meanwhile, twin magnitude 6 quakes ripped across Venezuela, while a colossal solar outburst collided with the sole verified interstellar comet traversing our solar system. Experts dubbed this intense period the 72-hour stack. Yet nobody anticipated such a simultaneous barrage, encompassing even Earth itself, which absorbed a direct blow from a coronal mass ejection. The chances of this blend of celestial and terrestrial upheavals are slimmer than 1 in 1,000. Could this be a bizarre coincidence? Or are we overlooking some underlying rhythm? It's a convergence of uncommon high-impact occurrences squeezed into just 3 days. Curious about the improbability? Let's dissect it. Globally, a visible nova graces the skies perhaps once annually, or occasionally not at all. Here, 2 such blasts lit up within a day and a half, each brilliant enough for casual skywatchers to spot from their own yards, no scope required. In Venezuela, that area usually endures a magnitude 6 tremor every 2 to 3 years. But 2 significant shakes, followed by a robust aftershock, hammered the identical spot in under 6 hours. At the same time, our sun, edgy amid its solar maximum, unleashed a CME that barreled straight toward the trajectory of an interstellar visitor, one so exceptional it's merely the 3rd ever documented. Crunching the figures, the likelihood of this entire sequence unfolding in one 72-hour span plummets below 1 in 1,000, or potentially far lower, based on the calculations. Experts term it Poisson clustering. Occasionally, chance deals out a combination so extraordinary it seems rigged. The probability of twin naked-eye novae in 3 days? Under 0.002%. Back-to-back Venezuelan quakes of that scale? Roughly 1 in 10,000. Factor in a CME grazing 3I/Atlas precisely as it ventures into the inner solar system, and the odds become so vanishingly small that math tools strain to compute them. That's precisely why veteran scientists are labeling it an event stack. Beyond the scarcity of each element, it's their intricate layering that renders the time frame seem downright implausible. The term is already buzzing in astronomy and geophysics communities, a quick way to describe a stretch when cosmic norms appeared suspended. The data speaks volumes. This qualifies as a premier statistical anomaly, which is exactly what renders it impossible to dismiss and irresistibly dissect, hour by hour, to grasp how snugly these improbable incidents interlock. The countdown kicks off shortly after midnight UTC. At 2:12 a.m. On September 23rd, the Nova V 1935 Centauri ignites into view. Observatories in Chile and South Africa snag the flare almost instantly via robotic systems, with alerts filed and official verification arriving in under an hour. In Centaurus, nighttime lingers, but by European morning, the buzz ripples across global channels. Jump to the evening of September 24th, precisely 22:21 Universal Time Coordinated. Seismic stations in the Caribbean detect a abrupt, shallow fault slip, a magnitude 6.2 quake off Min Grande, Venezuela. The focus lies roughly 7.8 kilometers down. There, evening clocks show 6:21 p.m., right amid mealtime for locals. Soon after, initial dispatches flood Venezuela's seismic networks, mirrored swiftly by USGS and EMSC in their worldwide logs. Barely 6 hours on, at 3:51 Universal Time Coordinated the next day, September 25th, the Earth trembles once more. Now a magnitude 6.3, plunging deeper to 14 kilometers. The surrounding territory stirs an alarm. Trailing jolts, one nearing magnitude 5.8, pulse outward over the ensuing hour. Hospital records and instant messaging threads capture the disarray live, as healthcare teams mobilize amid the turmoil. Merely 14 minutes post-second quake, at 4:05 Universal Time Coordinated, a fresh stellar ping sounds. V7994 Sagittarii blazes into sight, cresting at magnitude 6.2. Detection algorithms broadcast the find-to-open channels, while broad-spectrum instruments capture gamma-ray and X-ray traces. Hobbyists start swapping insights with pros. In the interim, solar activity builds to a pivotal juncture. Throughout September 25th, a CME ejected the day prior surges across the near-solar realm. Simulations peg its intersection with 3I/Atlas's route inside an 8-hour slot. Projections hover around midday UTC, though exact timing hinges on updated orbital data and solar wind speeds. Notifications from the Space Weather Prediction Center issue rapidly with each fresh datum, as astronomers and comet enthusiasts monitor the charged surge's advance. Though every marker ties back to UTC, each incident imprints its regional chaos. Chilly scopes in the early morning frost, Venezuelan clinics amid dusk power failures, solar specialists glued to evolving feeds. This layered cascade of happenings, etched moment by moment, weaves a chronicle as packed as any in modern recollection. Every pinpoint marks a spot on the chart of an incredible 72-hour period. A nova represents far more than a mere flare-up. It signifies a violent outburst on a white dwarf, a stellar remnant that stealthily draws hydrogen from its orbiting partner until those vital elements trigger uncontrolled nuclear fusion. Within mere hours, the star's luminosity can explode by a factor of 100,000, surpassing the brilliance of a billion suns. Such an event unfolded right before dawn on September 23rd, as V1935 Centauri, a dim object in Centaurus, surged to magnitude 5.8. That's barely visible to the unaided eye from a clear, dark site, a phenomenon even experts rarely witness. Gabriela Moya, a dedicated hobbyist astronomer based in Valparaiso, Chile, became the initial verifier of the flare. She dedicated the evening to operating distant telescopes, hunting for anomalies. Battling overcast skies and electricity failures, she pushed forward, fueled by excitement and the pressure of pioneering the observation. Whispers of the nova circulated in Discord groups. Yet Moya held out for solid proof. By the time her update arrived at the Central Bureau for Astronomical Telegrams at 0212 UTC, she had gone without proper rest for over 48 hours. Her notification sparked a cascade of robotic verifications throughout the southern skies, and shortly after, the nova's position lit up international data streams. The allure of a nova stems from its underlying mechanics. Hydrogen gathered from the companion accumulates on the white dwarf's exterior, squeezed by gravitational forces until heat exceeds 10 million degrees. The fusion process spirals out of control, hurling surface material into the cosmos at speeds of thousands of kilometers per second. This detonation generates a pressure front that tears through the expelled material, superheating it to emit light in the visible spectrum, along with intensified gamma rays and X-rays. For V1935 Centauri, space-based instruments detected distinct gamma-ray and hard X-ray signals precisely as the visible glow crested. These serve as hallmarks of intense collisions. They indicate the eruption propelled particles close to the velocity of light and may have even produced microscopic dust particles in its wake. Just under 48 hours afterward, a separate white dwarf in Sagittarius, dubbed V7994 Sagittarius, ignited similarly, hitting magnitude 6.2, right at the threshold of baryon detection. The find ignited arguments as various observation groups vied to assert priority in spotting it, with their accounts zipping between observatory records and online platforms. Energy-focused orbiters such as Fermi and Swift registered the occurrence nearly immediately, logging a sharp rise in gamma and hard X-ray fluxes. Discussions within NASA and the Fermi Group postponed the official disclosure while scrutinizing the readings for errors. Once validated, announcements flooded in via preliminary papers, each delving into the collision dynamics and particle boosting tied to the explosion. Connecting these novae is the ferocity of their collision indicators, evident in both the brightness profiles and energetic outputs. Far from subtle glows, these are thermonuclear detonations erupting in distant binary setups light years off, yet vivid enough to inscribe their narrative onto our night sky. The initial tremor hit shortly after dusk, close to Manet Grande, clocking in at magnitude 6.2 and only 7.8 kilometers deep. That proximity to the surface allowed the break to propagate directly upward, jolting residences and whipping utility poles. The nearby medical facility, already low on resources, hastily organized emergency sorting in the open air amid incoming jolts. Veteran caregiver Maricela Rivas, fresh off duty, plunged right back in, directing individuals to designated mats laid out in the lot. Her calm directives via the facility's WhatsApp network conveyed wound assessments and pressing requirements as helpers assembled temporary hydration points and shifted the gravest injuries clear of damaged structures. 5 hours on, the earth shuddered once more. Now a magnitude 6.3, seated at 14 kilometers down, but aligned nearly under the prior zone. The progression mirrored a standard strain migration, one fracture segment yielding, then stressing the adjacent one. Researchers from the University of Los Angeles, laboring overnight, traced the tear's advance across the Oka-Anon fault system. Their breakdown highlighted a standard post-event decline, termed a More's Law. The strongest jolts first, followed by diminishing quivers. In under 60 minutes, a magnitude 5.8 follower shook the vicinity, compelling another exodus of occupants and personnel from the structure. Kitchen staff at the hospital doubled as lookouts, eyeing barriers for new fissures and signaling clearance to re-enter. The early response hinged on quick adaptations. Limited to 3 surgical setups and sporadic electricity, Rivas and her colleagues focused on young patients and dire injuries. They shifted cases outside during tremors, relying on handheld lights to insert drips and track life signs. Community broadcasters shared dispatches from the site, airing requests for essentials and secure paths for rescue vehicles. During that stretch, the center evolved into a hub not only for treatment, but also for updates and collective organization. Experts examining the tremor series stressed that despite the sequence of tremors adhered to familiar seismic principles. In this region of Venezuela, the tectonic plates of the Caribbean and South American varieties exert ongoing pressure through their gradual collision. A shift in one section can shift the tension, potentially sparking a fresh break in the vicinity. These subsequent shakes served as a stark indicator that, amid a period when cosmic probabilities appeared to defy expectations, the ground underfoot remained governed by its inherent laws. This year's solar peak represents far more than mere jargon. It forms an everyday occurrence. Counts of sunspots have climbed to 165, with solar radio emissions steady above 180. Such conditions foster frequent coronal mass ejections, as the star regularly expels thick bursts of charged particles several times weekly. Yet the novelty lies in the entity now traversing the inner solar system alongside these eruptions. 3I/Atlas. As merely the third verified interstellar visitor, 3I/Atlas defies conventional paths. Its course runs sharply backward, barely grazing the ecliptic plane, and it hurtles along at more than 60 kilometers per second, far quicker than ordinary comets. This path draws it to within 0.19 astronomical units of Mars on October 3rd, prompting Mars mission crews to prepare for potential photo and spectral analysis chances. Unlike the comets we typically examine, which originate from the Oort cloud or Kuiper belt, 3I/Atlas hails from a distant stellar realm, bearing substances and ices older than our own sun. Its arrival proves remarkably timely. Traversing our solar system at the height of cycle 25, it encounters the most dynamic and potent solar wind we've witnessed in over 10 years. This positions it as an ideal test for plasma dynamics, with its surrounding gas envelope and trail offering live insights into how alien matter reacts to fierce solar disturbances. Dr. Stephen Burns, a geophysicist renowned for research on Sun-Earth dynamics, describes this transit as a rare, era-defining trial. He emphasizes that although we've observed ejection effects on local comets previously, this marks the first opportunity to scrutinize such an event on an extraterrestrial interloper. The near-Mars pass heightens the intrigue, spurring planet experts to align data collection from satellites like TGO and MAVEN. Each piece of information collected could illuminate the comet's backstory, as well as the mechanics of charged particle behavior during solar maximum. Thus, as 3I/Atlas glides by Mars en route to its nearest solar point on October 29th, it transcends mere interest. It emerges as a precious, dynamic focus for solar and planetary studies. The star's intensified output, the object's eccentric route, and this rendezvous schedule transform an ordinary solar outburst into a fleeting research windfall. October is shaping into a landmark period, featuring multiple intervals for enthusiasts and citizen scientists to participate hands-on. The upcoming key moment arrives on October 20th and 21st as Comet Swan, C/2025 R2, nears Earth at just 0.26 astronomical units, roughly 39 million kilometers distant. Coinciding with the new moon and the Orionids showers climax, the setup offers prime visibility for the comet's dim trail. For optimal sighting, venture out post-midnight, away from urban glow, allowing your vision 30 minutes to acclimate. Optics around 7x50 or 10x50 magnification aid greatly. A celestial map or mobile application will direct you to Swan's spot as it drifts across the early morning heavens. Come October 29th, 3I/Atlas hits perihelion, its sun closest mark here at about 1.36 astronomical units. Though not discernible in daytime, seasoned spotters might attempt crepuscular or morning efforts, exercising utmost care. Avoid gazing toward the sun sans ISO 12312-2 approved filters, and refrain from optical aids without a firm filter on the objective end. A momentary unprotected peak risks irreversible vision loss. In pursuing comets and novae, endurance yields results. Acclimating to darkness matters most, while crimson lights or subdued displays safeguard low-light sight. The final prominent occasion falls on December 19th, with 3I/Atlas at its Earth nearest, around 1.8 astronomical units off. Here, the object shines brightest for hobbyist photos and naked eye checks, particularly should its outbursts intensify post-perihelion. Networks such as AVSO, the International Comet Quarterly, and the Comet Observation Database are issuing invitations for brightness ratings, tail drawings, and sequential images. Spot an oddity, like abrupt flaring, a twisted extension, or a potential fragmenting. Note the timestamp, site, and gear, then cross-reference with peers prior to submitting formally. Thoughtful submissions sift true finds from clutter, ensuring the info aids pros effectively. For leading collective stargazing sessions, particularly involving youth, cover essential precautions at twilight start. Prohibit any unshielded solar peaks. Secure all viewing tools, aim optics safely distant from the sun's glare, and share alerts on verified filters along with proper laser handling. The thrill of such spectacles might encourage risky cuts, yet a brief pause in vigilance safeguards vision and research integrity alike. With October and December on the horizon, the heavens extend an uncommon beckoning, one ideally met through sharp vision, meticulous practices, and a balanced awe for marvel and precaution. Within a mere 72 hours from September 23rd to 25th, 2025, observers witnessed two naked-eye novae, paired magnitude 6 quakes in Venezuela, and a coronal mass ejection crossing paths with 3I/loss. The recorded odds of this sequence unfolding hover below 0.1%, as fresh insights roll in from key events ahead, like the Mars flyby, Swan's approach, and perihelion. Group sightings and thorough scrutiny will distinguish chance from true links. The evidence endures. Occasionally, the cosmos's most elusive designs emerge right before us.